Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the channel Chemistry Unlocked by Firoz sir. Today we will discuss about the topic hybridization, which is very much important for the students already in HSC and also for A levels. So, we will discuss it in details. First, we have to know about the definition of hybridization. So, let us go for the definition of hybridization. Hybridization. The process of intermixing the pure atomic orbitals in an atom to produce hybrid orbitals having identical shape and energy before bond formation is called hybridization. Basically, hybridization is the process of intermixing orbitals. It is happening in a single atom, but the hybrid orbitals will participate later in bond formation. So, you must clear about that. Hybridization is not the mixing of orbitals between the two atoms or more atoms. Between the two atoms or more atoms, bond will be formed, but the thing is that we have to know about hybridization, that it is the intermixing process of orbitals in a single atom, and that single atom will again participate in bond formation. So, bond formation is later, hybridization is earlier. Okay. Whatever, we will discuss the definition through the example, then it will be more easy for you. Now, it's a very common example, an example just for knowing the definition of hybridization. CH4. You know that CH4 is made by carbon, and the electronic configuration, the carbon is 1:2, 2:2 and 2px1, 2py1 and 2pz0 at normal state. But at excited state, it will be like this: 1:2, 2s1, 2px1, 2py1 and 2pz1. So, now the number of unpaired electron is here 4, and the number of orbitals in this valency shell is 4, that is 1s and 3p orbitals. So, if these orbitals are intermixed together, then the process will be what? sp3, hybridization. Why sp3 and why sp2 and why sp3d? I will discuss it details in the upcoming lecture, but first we have to know the definition. Okay. So, here number 1 s and number 3 p orbitals will be intermixed together. So, we will get the number of total orbitals that are hybrid will be 4. So, 1 is 2, then psi 1, psi 2, psi 3 and psi 4, and these electrons will be distributed again among these hybrid orbitals. So, these are the 4 number of hybrid orbitals. They are all known as sp3 hybrid orbitals, and the symbol is known as psi. This is psi, SiGH. This psi is used to indicate the hybrid or hybridized orbitals. So, what will be the diagram for this hybridization? You know here 1s, okay. So, S shape is what? Round shape, you all know that. So, round shape, here 1 electron, that is what? 2s1. Now, the 3 p orbitals like this. So, px, py, and finally what? Pz. So, 3 number of p orbitals, 1, 1 and 1 electrons in each orbitals. So, here sp3, why sp3 again? Here number of s orbital is 1 and number of p orbital is 3, 2px1, 2py1 and 2pz1. Now, they will be intermixed together, and the process will be known as what? sp3 hybridization. So, here sp3 means 4 number of orbitals are participated here, and these orbitals before intermixing are known as what? Pure atomic orbitals. Listen my dear student, pure atomic orbitals. So, when orbitals are not intermixed together, they are what? Pure atomic orbitals. But after the hybridization or intermixing process, the hybrid orbitals will be produced. So, here 4 number of hybrid orbitals will be produced. So, here 3 and here 1, and they will make the new orbitals number 4, 1, 2, 3 and 4, and that is present in the valence shell of carbon, and here every orbital will be name will be sp3 hybrid orbital. Okay. So, this is sp3 hybrid, this is sp3 hybrid, and this is also. So, now this C is written just for indicating the nucleus of carbon and connecting that orbitals to the nucleus of carbon. These are the sp3 hybrid orbitals, and having each orbital a single electron. Now, this carbon is ready with its unpaired electron in each hybrid orbitals for doing bond formation with the other atom. For example, we have taken here methane, that is why here we will show the bond formation of carbon with the other element hydrogen. Okay. Now, we will draw the diagram of bond formation. We will draw the diagram of what? Bond formation. So, now bond formation. Bond formation. So, this carbon 1, 2, 3 and 4. This is carbon having the unpaired electron 1, 2, 3 and 4. Now, this will be paired by the head to head overlapping of the unpaired electron provided by hydrogen atom like this. So, this is sigma bond, this is sigma bond. You know that covalent bonds are 2 types, one is sigma, another is pi. So, when head to head overlapping, this is sigma bond, When sidewise overlapping, then it will be what? Pi bond. Just this example is given to you to understand the definition. So, these hybrid orbitals are produced in the valence shell in this carbon atom, and these hybrid orbitals participated in the bond formation with another atom of what? Hydrogen. Now, types of hybridization. Types of hybridization. Types. For example, in types sp, sp2, sp3, sp3d, sp3d2, sp3d3, like this. Now, when will be sp, when will be sp2? So, we have to know some rules to select the hybridization process present in a particular molecule. So, now we will find out the rules. H equal to half V plus X minus C plus A. So, using this formula, we will find out the type. For example, again CH4. You know, carbon atom has 4 number of unpaired electrons, or its valence electron is 4. So, 4 number of unpaired electron. So, we can write here H equal to, here V value is 4. What is V? Come to the point. V is valency electron. V is what? Valency electron. X is what? Number of monovalent atoms. C is what? Number of charge on cation. A is what? Number of charge on anion. So, come to the point again. Here the valence electron of carbon is 4. That means V value is 4. X is the number of monovalent atoms. Monovalent means valency 1. So, the atom having the single valency are known as what? Monovalent atoms. If the valency is 2, that is divalent atoms. Di means 2. So, it will be discussed later, inshallah, in the next lectures. So, here X value is also 4, because here the number of monovalent atom is 4. So, here plus 4 minus 0 plus 0. Why 0? Because this value is applicable for what? Cation, and this value is applicable for what? Anion. So, this methane is not a cation because it don't have any positive charge or negative charge for anion. So, this CH4 don't have any positive or negative charge, so their value will be 0. Now, final calculation from this formula, that is 8 and here 4. 4 will be sp3. This. Now, what will be the value for the other type of hybridization? Now, come to the point. Come to the next point, like this. Wait a minute. Value of H or Z. Value of H or Z. That means that instead of that H, you can use also Z. So, if the value of H is 2, then hybridization type, hybridization type will be sp. if it is 3 sp2, look at here, 1s and 1p. Again 1s and 1p will define the type of hybridization sp. That means the hybridization process in which one number of s and one number of p orbitals are intermixed together, and they will produce number of 2 hybrid orbitals, because number of participated orbitals in the hybridization process will be equal to the number of produced hybrid orbitals. So, sp hybridization process will make 2 number of sp hybrid orbitals. So, how will be their arrangement? What will be their arrangement? Like this. What will be their arrangement? Like this. Like this. Now, come to the point, their bond angle will be what? 180 degree. Now, question may be arise from this diagram. So, I will make you understand very soon. Wait. And its bond angle will be what? 180 degree. And it is the hybridization geometry. Hybridization geometry. That means how the hybrid orbitals are arranged together. Okay. This is the hybridization geometry. Now, try to understand the diagram. This is a sp hybrid orbitals, for example. So, any hybrid orbitals having 2 parts, that is larger lobe, and this is what? Smaller lobe. Smaller lobe. Lobe means part. So, every hybrid orbitals having 2 parts, that is larger lobe and smaller lobe. But most of the time we draw the larger lobe. So, avoiding this smaller lobe, it is not a major mistake. So, you can avoid that during the total drawing of a diagram in a molecule. So, we can avoid that. Okay. For example, now sp2, 1s and 2p will make 3 number of hybrid orbitals. So, 1, 2 and 3, and they will be arranged like this, and their bond angle is what? 120 degree. Divide this 360 circle by 3, then every bond angle will be what? 120 degree, and here the maximum distance is 180 degree. Actually, the hybrid orbitals repel to each other and they try to make a maximum distance from each other. So, 2 hybrid orbitals will make the maximum distance like this. Like this, they will make the maximum distance between them, like this. Maximum distance is what? 180 degree. Now, when come the 3 orbitals, then they will be present in a same plane like this. That is trigonal planar shape. Look at here, trigonal planar shape, 1, 2 and 3, and their bond angle is what? 120 degree, because this circle is what? 360. So, if we divide this 360 by 3, then every angle will be what? 120. Now, this shape is what? Linear shape, and this is what? Trigonal planar shape. Okay. And every name of this orbital is what? Here sp hybrid orbital, and here the every hybrid orbital name is what? sp2 hybrid orbitals. Okay. Now, we will come to the next type 4. If the value of h or z is 4, then it becomes what? sp3. So, very simple, 1s and 3p will intermix together and we will get 4 number of hybrid orbitals like this, and here the arrangement is tetrahedral shape, and the bond angle is what? 109.5 degree, and the hybrid orbital's name is what? sp3 hybrid orbital, and the shape is what? Tetrahedral shape. tetrahedral shape. Now, how they are arranged practically? Actually like this. Just imagine a tripod like shape, tripod like this is the tripod shape, and another is here like this. Look at here, my dear students. Here the bond angle is what? 109.5 degree, and these orbitals are dispersed in the three-dimensional space, not as one plane, right. So, here the bond angle is what? 109.5 degree. Now, the next type is P3D. Is P3D. Is P3D. 5. Hybridization type is what? Sp3D. So, one is 3p and 1d. So, total hybrid orbitals will be produced, that is 5. And how they are arranged? Trigonal. Try to understand this trigonal shape. So, in a trigonal shape 1, then 2 and then what? 3. So, left 2 will be like this, okay, like this. So, trigonal bipyramidal. This is what? Trigonal bipyramidal. And what will be the bond angle? Look at here. Trigonal bipyramidal shape. Look at me, students. Like this. This is the trigonal shape. It means the 3 hybrid orbitals are present in a same plane, trigonal shape, and here 1, 4 and the here 5. So, trigonal bipyramidal. So, what should be the bond angle? You know that this is the perpendicular and this is also perpendicular, but this is trigonal arrangement. So, trigonal arrangement will provide you the bond angle 120, but the perpendicular and this perpendicular will provide you the bond angle 90 degree. So, here the bond angle will be 2 types, that is 90 degree for the perpendicular arrangement, and this is for what? 120 degree. So, this shape is what? Trigonal bipyramidal. Now, 6 Sp3D2. Sp3D2 will provide you 6 number of hybrid orbitals. It's very interesting thing is that the value of H is equal to the number of hybrid orbitals. Value of H is 5, number of hybrid orbitals is 5. Value of H is 6, number of hybrid orbitals is 6. I think you will understand properly, inshallah. Now, for Sp3D2 diagram, okay. Sp3D2 diagram is arranged like this way, square bipyramidal. You know that square shape 1, 2, 3 and 4. So, here in this way 4 hybrid orbitals are arranged, remaining 2, and this remaining 2 will make this like this. So, here the bond angle is 90 degree, here 90 degree and perpendicular is also 90. Like this in the square shape, if you think that if this 2 straight line cross in this way, every bond angle is what? 90 degree, right. So, it is what? 90 square shape, and here perpendicular shape 1 is 90 and here another perpendicular shape, yes, it is 90. So, every bond angle is here 90 degree in square bipyramidal shape. So, its name should be square bipyramidal, square bipyramidal. Okay. Now, the last one is sp3d3, sp3d3, sp3d3. Dear students, 6 here sp3d3. So here this number of hybrid orbitals will be 7, because 3, 3 and 1, that is 6 and 1, 7. So the diagram will be like this: pentagonal, pentagonal 1, 2, 3, 4 and 5. So 5 hybrid orbitals will be arranged and plane pentagonally. So their bonding will be what? 72 degree. Why 72 degree? Look at here. If we divide this 360, for example here, if we divide this 360 circle in the 5 part, 1, 2, 3, 4 and 5. If you divide this 360, divide in your calculator, 360 divide 5, you will get 72. So every bond angle here which are arranged in this pentagonal way, pentagonally, they are what? 72 degree. But rest of the orbitals which are present in this way, in a perpendicular arrangement, so their bond angle will be what? 90 degree. So their shape is what? Pentagonal bipyramidal, pentagonal bipyramidal, but their bond angle is what? 90 degree and 72 degree. So my dear students, in this video we have discussed the definition of hybridization, type of hybridization and the geometry of this type of hybridization. But every type of hybridization has a huge example and huge discussion with their bond angle. It is very difficult to make all the concepts in one lecture. So we will discuss later in that videos, in the upcoming videos, about the detail like SP, SP2, SP3, SP3D, all with example. And if you have any question, any suggestion, any advice, you can provide me in the comment section. Till then, Allah Hafiz. Keep you smile all the time and keep joined with our channel Chemistry Unlocked. Assalamu alaikum.